notes. Make sure you're looking at the notes and not the assignment that you just picked up. And let's do number 4. So we need to start off by factoring, right? So we're going to factor this. This is x minus 3 times x minus 1 over x minus 2. Do I have any point discontinuities? No, so I put none here. How many roots do I have? 2. So I have x equals 1 and 3. How many vertical asymptotes do I have? 1. So that is x equals 2. Do I have any tangency or togetherness? No. Do I have a horizontal asymptote? Is it top heavy, bottom heavy, or tied in degree? It's top heavy. It's top heavy, which means this is none. Is it top heavy by just 1? Yes, which means I have a slant asymptote, so I need to divide, and I want to use this form for the division. Can I use synthetic division? Yes. So put a 2 here. I make sure I look for missing terms. If this is x squared, I should have 3 numbers I write down. I do, so 1, negative 4, and 3. So the synthetic division should go quite quickly. This is 1, 2, 2, negative 4, negative 1. So my slant asymptote is y equals x minus 2. My y-intercept is going to be 0, and then when all those 0 out, negative 3 halves. There we go. Okay, everybody with me? All right, so now I'm going to scroll and rewrite this and do my sign chart. Scroll here. I'm going to get f of x is equal to x minus 3 times x minus 1 over x minus 2. Okay, so there's 3 things that go on my sign chart. I have a 1, a 2, and a 3. So does the 1 get an open or closed circle? Closed. 2, open. 3, closed. Okay, so I substitute in 0. That's going to give me negative, negative, negative. That's negative overall. Can substitute in 1.5. That's going to give me negative, positive, negative. That's positive overall. 2.5 is going to give me negative, positive, positive. That's negative overall. 4 is going to give me positive, positive, positive. That's positive overall. All right, so I shade. Then I'm going to go ahead and draw my asymptotes in. So I have one at x equals 2. And then I have a slant asymptote. Got to make sure I graph that correctly. That is y equals x minus 2. What is the y-intercept for that? Negative 2. What's the slope? 1. So I can start at negative 2. My slope is 1, which means I just make sure I go diagonally through the little boxes. Ugh. Straight edge would help, but a straight edge only helps if your straight edge is in the correct place. So make sure that you don't necessarily have to have a straight edge because you're going to do a dotted line and go through the diagonals. It would look something like that. Okay. So let's talk about the placement of our function here. The function could be here. So if I have a piece of the function right here, then the other piece has to be opposite of it right here. I couldn't have a piece here and a piece here. Right? I could have a piece here. If I do, then the other piece is down here. You see how they're opposite of each other? And depending on the graph, it could be one or the other. But can I cross, is it possible to intersect a slant asymptote? Yes, it is, right? So we have to check to see if we do. So in order to do that, we use the unfactored form. So if I look back up here, I'm going to use this form here to help figure that out. Now, if I had canceled stuff out, then I would use the reduced form, but multiply it back together if necessary. But since I didn't reduce anything, I can just take that piece up there. So that means I have y equals, it was x squared minus 4x plus 3 over x minus 2. And my slant asymptote is y equals x minus 2. So I'm going to handle this the same way I did the horizontal asymptotes with substitution. So this x minus 2, I'm going to substitute in for y right here. So I get x minus 2 equals x squared minus 4x plus 3 over x minus 2. Can I cancel out the x minus 2's? The answer to that is no. Okay? So totally can't do that because this is equals. If I was multiplying, yes, but that's not what's happening. I need to get rid of my denominator. So I'm going to have x minus 2 times x minus 2 equals x squared minus 4x plus 3. So then I have to multiply this together correctly and accurately and efficiently. So this is x squared minus 4x plus 4. That equals x squared minus 4x plus 3. So when I go to solve, I can subtract x squared from both sides. That zeroes out. I can add 4x to both sides, makes that zero out. I'm left with 4 equals 3. Does that make any sense? No, so what does that tell us? It doesn't intersect, right? Okay, which is something we need to know. So we got nonsense, that's fine. Okay, so now I'm going to go in here and plot what I do have. I have a root at 1, and I have one at 3. And I have a y-intercept at 0, negative 3/2. Okay, so I have these 2 points over here, and so this has to hug this slant asymptote. It doesn't get to intersect it, and then it's going to have to hug that vertical asymptote, so it's going to look something like that. And from negative infinity to 1, my function's negative, so that makes sense. From 1 to 2, it's positive. From 2 to 3, it's negative, and from 3 to infinity, it's positive. Okay, so let's say that I didn't have this point here. All right, let's say that it just gave me these 2 points, and I was going to go and have to figure something else out. Because this piece is here, I know for a fact I don't have a piece of the graph here or here. It has to be over here, which I'd figure out once I had to substitute in a point anyway. Okay, but figuring out whether or not you have enough points to go ahead and sketch it, or if you need more, has to do with how close your points are to the intersection of the asymptotes. I mean, if this one point was way out here, I would need something else to see if I come any closer to the inside. But this is pretty close. I get the idea of what's happening here. So I think that those 2 points over here are enough. And it would just look something like this. And then this, even though this is just 1 point over here, I think that's enough. Because it can come in and go like this. Okay. And that's what that function looks like. Any questions on how I knew how to do anything or where anything came from? We all good? Okay, perfect. So then you're going to have the rest of the class to graph those 4 that are on that assignment you picked up.